Hello.
Everyone, can you guys hear me?
Yes, we can hear. I can hear you.
All right, thank you. All right, let's get started. This is ITS 454. So today we are going to, let's see the chat here. Oh, okay, yeah. So today we're going to continue with the VPN lab. Okay, let me just make all right, so before I get started, are there any questions about anything? You know, I know I keep repeating things, but I feel like I have to, because, you know, people may not be in the loop, right? So currently we're working on one lab, which is the VPN lab, right? And then you still have two projects. There is the risk assessment project where you guys can, you know, use a real company. Unfortunately, we don't have access to the university this right now, and so you can just make up a company and just do the risk assessment. Remember, I posted a video about that, and then you will be doing your presentations, possibly through Zoom, at the end of the semester. And then, additionally to that, I mentioned that you have a project B, which is going to be either extending the VPN lab, which we are currently working on. From the lab is to be in VMs, but maybe you guys can extend it to some application, or possibly also I wanted to give you some options. So actually, I'll talk about that. So there's really three options, and let me go back here. Did somebody ask something? I need to share my screen, right? Okay, so I just shared my screen. I know this is a little bit repetitive, but I just want to make sure this is, if anything, I'm going to take some time since I have some of you here and to speak with you about this. So as far as projects, right? Can you guys see my whiteboard now? I'm writing on it.
Yes.
Yeah, sure.
Great, great. All right, so for the project, for the class, for 454, right? So we have, let's say, three options, let's say. I had some emails, so I thought about a third option. So one option is you're currently doing VPN lab, the CVPN lab, right? Using just VMs. However, you might decide that you want to extend this. But it has to, so basically the idea that I gave is maybe in your home, you know, you have your classmate, right? And then you guys want to use that code to basically, through your home routers, if you can, you know, you need to have access to the routing rules, et cetera, you might implement that code, right? And then you can build a VPN. So some ideas that some people had given actually were very interesting. You know how when you build a tunnel, you know, you can send netcat and things like that, ping, but you could, not netcat, telnet, right? But you could also, if you think about it, you could use netcat, and I think we did this in 372, and you can build a chat. So now you have a little chat and it's going through an encrypted tunnel. So I think that's just pretty simple. But someone, I did like this idea, you know how I think the word of the year 2020 is going to be Zoom, honestly. because I hear that so many times in a day now. And if you think, what if you guys decided, okay, I'm going to do my own video conferencing? That would be a nice thing, you know? So like if you build, you know, some application, you can leverage some applications, and then you guys, just like you,
to pretend to be a virtual.
You can try to do a video through the encrypted tunnel. So the point is you can build a service on top of that VPN. Again, that's just an idea. I'm not saying you have to do this, but this is one possibility. So I would say for the project, extend your VPN code from the lab. The other idea is, you know, I covered, you know, in the class we covered firewalls, we covered IDSs, and then on Tuesday I covered anomaly detection algorithms, right? And I explained that. Hopefully you were in the session or you saw the video. But if you notice, I'm not assigning a lab, or I'm not assigning, I'm not giving you any code or anything like that. However, because my intention is you could also extend this or implement this in any language that you would like, and maybe do this for your project, an anomaly detection algorithm, right? So that's the idea. And then the third one, you know, I did get some thoughts from you guys about this, and well, you know, I can leave it open for a third idea. If you guys have a great idea, just run it by me. So for instance, you know, unfortunately, one of the labs that we were gonna do is the one I've said. We were gonna build, you know, with our network, right? You would have a domain controller here. And then you would have Active Directory services, and Radius. And they're just basically authentication devices, right? So those are two services in the Active Direct. So the way to think of this is this DM is server. What is the current Windows Server version right now? Anyone that knows? Daniel.
2016.
What is it?
I think it's still 2016. That's the one I'm seeing at work.
All right, there we go. So Windows Server 2016, right? And so then you could have a VPN client over here. I mean, a lot of this revolves around VPN. We have to cover, you know, the TLS and all that. So you could then maybe, you know, try to implement this in some kind of virtualized environment. I doubt that you have this at home. I don't think there's any ASA VMs. Okay, so that's I've looked. There's something called GNS3 and software like that, but it's very rare to find actual VMs of things like ASA. But some students talked about the cloud, like AWS. I think I was talking with someone who thought about that. So anyway, I could leave this open-ended, and you could try to figure out, but just talk with me about it, right? So how you would do it, and we can maybe agree on a plan. And then finally, I guess number 4, your own ideas. Your own ideas. So as I said, you know, this is kind of an evolving thing, given that we have different circumstances right now. So your own ideas, and then, you know, as long as it's related to network security, to the class, maybe it's something interesting, right? So anyway, remember the presentations would be done the last week of before finals. So we have a final during finals week, and then we would have the week before finals, you would do the presentation for RCM, and then the presentation for one of these ideas. So what I'm gonna do is, right now, I'm gonna try to do what I usually do in class. And I'm just gonna talk to every one of you that's online right now. to see which direction you're leaning on, but I want to push you to, you know, as I would in the class, to be working on this. Does this make sense?
Yes.
Okay, excellent. So let me, I'm gonna open up the manage participants, and I'm gonna pick, you can work on this in groups, okay? So let's see, I'm just gonna go, I'm gonna call your names. Oh, I apologize. I have to. All right, so let's see. Susanna's group.
Yes, we're here.
Susanna, are you there?
Yes,
Yeah,
I'm
we're
here.
all here.
I'm here.
So Susanna, Kyle, and Tink, right?
Yep, that's us.
Okay, guys, so this is a project, you know, kind of have to work outside of class time. Are you leaning towards any of these possibilities?
Mm,
I mean, well, we didn't know that we would possibly have to be able to choose our own ideas. I think my group would agree with me that choosing own idea might be good, but we haven't had time to actually think of that. So
Right. And I just threw that at you right now. Just keep in mind, you know, it has to be, you know, you have to run the idea by me first, right? So that they're all equally complex. These two have a level of complexity, right? And so you know, your project also has to be around that level of complexity, okay?
okay.
I know Tink loves math, so the anomaly detection one sounds like a good,
Yeah, there's that.
right?
Yeah.
So
They know the first one's not going to happen.
okay, so that's, yeah, and I get that. I mean, some students told me that they had no access to their routers at home. They couldn't, you know, obviously. But I do suggest think about it. Okay, guys. So I'm going to move on to another group.
Okay.
As I said, you know, I have to do this like this, otherwise. Who else is here? So, Yang Shangxi, you're with you're
Ali and
are you
Jackie.
there, Shangxi?
Yeah,
Okay, and you work with Jackie, I think, and Alicia. Yeah.
Yeah.
Okay. So, have you guys thought about this project?
yeah. We talked about it yesterday, and I asked Alicia,
And your
and
idea?
she like to do the IDAs, the detection,
The anomaly. This is not an idea. This is anomaly.
normal detection.
Do you want to do that one?
Yeah, we're thinking about it.
Okay. Jackie, do you have any thoughts on that? She's not there. All right. So, okay. At least you guys are working on it, thinking about it. Okay. I can see Corey just signed in. Corey is with Mitch and Nathan, correct?
Yep.
Are you all there?
Yeah, I'm here.
Okay.
Yeah.
Okay, Corey. All right. So, which one of these four are you leaning towards?
We were thinking about doing the anomaly detection.
The anomaly detection as well. Okay,
Yeah.
sounds good. Good. All right. Let's see. Daniel Cook, you're with Sihao Fan, correct?
Yes, and Zhedong.
Yeah, Jadong. I don't see him, but
He's here.
oh,
I'm
he's there. Okay, I didn't see you. Sorry. Sihao, is he there?
Yeah, I'm here.
Okay, great. So, what about you guys? What are you leaning towards?
We had spoken when there was just the two options.
Yeah,
and
no, I get that, but
with those two, we were thinking towards the VPN.
okay.
We haven't discussed the other two options at this time yet.
So you're gonna think about it then.
Yes, we'll discuss some more.
Okay, great. That sounds fair. But just try to get back to me as soon as possible. What I'm trying to do here is I'm trying to get this moving, right? So,
Okay.
yeah. So, okay. Wenliang Chen, Shashing, and Sing Li. Can you guys,
We decided to do normal detection.
you want to do anomaly detection?
Yes.
Okay, great. So that sounds good. All right, perfect. See who else do we have? Trevor, Portinga, Evan Brady, and Nathan Buss. Neil Buss. Neil, all right. You're there, Neil?
Hello. Yeah, I'm here.
Okay, and Trevor?
He is also here. I
He's
think
also there.
Evan
and
is
also,
on his way.
Evan?
He's on his way, I believe.
He's on, yeah, it doesn't matter. It's okay. I mean, you can always watch the video, but I just want to know, have you guys given any thought to this?
Yeah, we wanted to go ahead and do the VPN.
Oh, great. That's excellent. Then, like I said, implement, assume, or, something that, beyond just pinging and telnet. You know what I mean?
Yeah.
Nothing too big though, right?
Okay.
You can use, for that, you can use services that already exist and just see if they'll go through your tunnel, that kind of thing.
Got it. All right.
That
Thank
would
you.
be really, really nice. All right. Very good. That sounds like a great project. Your own Zoom. All right. So let's see who else. Did I miss anyone, guys? Have I missed anyone? Okay. Okay. Unfortunately, I don't know what that is. Okay. Yes. So please, if I haven't called your group or your name, please speak or raise your hand or something. All right. And then for those of you that are watching the videos at home, not online, please get back to me as soon as possible and give me a topic. Okay. Just so that I know what you're working on. All right. So let's call this project B. Okay, so let's call that project B. All right, now I'm going to repeat the same thing for project A, and that's just because I've also not received many replies about this. So project A is the RCM, and there's a video for it, right? Hopefully you've all seen it. Okay, so once again, I'm going to kind of do the same thing. Tink's group. Tink, Susanna, Kyle. The risk assessment. I explained in the video, you would have done this in the buildings of the university, but now we kind of just have to do that risk assessment. If you know of a company or otherwise, you can it could be a made up company at this point.
Yeah, I thought we had decided, right, Kyle?
Yeah, I think we all voted on doing a fictional company because that would be easier than trying to work with a real company. Because when I thought about real companies, I thought about possibly asking Tink's company, but then I dismissed the idea because I think they would say no anyway.
Yeah.
No, it's like I said, it's perfectly fine. Okay, that sounds good. I just want to make sure you're all working on this. Okay, so let's see. Next group, Daniel and Yadong. Guys?
I don't think we've discussed this yet.
Yeah.
I know I had talked to a company owner and was heading in the direction to ask him this, but I haven't actually asked him at this point.
It has to be someone that's big enough, right? That they do have an IT infrastructure, that kind of thing.
Oh, then this company wouldn't be that big.
Yeah, not a startup or, we just have some local computers. You do want to think of this as a mid-sized company. So if you have access to that, that'd be great. got to be a made-up company of some kind.
Okay.
All right. So that basically, guys.
I don't think we have any other choice.
All right. There we go. Okay. Changshi and Jackie and Alicia. How about you guys?
I figured we'd probably just go with the fictional company, because that would
Fictional,
probably
okay.
be easiest.
Okay. Yeah. All right. Thank you. Wen Liang, Xiaxing, and Xing Li.
And so we're still looking for the company with mid-size, and we can pick.
Okay. So you would work with a company, or you would a made-up company? Company and research it online.
We
I
are
guess,
just
isn't it?
make up a company.
Okay. All right. Neil, Bus, Trevor, Evan.
Yeah, we're gonna go with a made-up company.
Made-up company. Okay. All right. Mitch, Burke, Corey, and Nathan.
We were thinking we were going to go with a makeup company.
Okay, made-up company. All right.
Yeah.
Okay. All right. So at this point, at least we've talked about this, and I believe everyone is now aware of that. All right. Is there anyone that I missed by any chance? Okay. All right. Okay. So yeah. So that worked. So good. So remember, both your projects are assigned, and you've selected what you're going to be working on. Project A and B. Okay. And so now you have basically, again, I'll repeat, what we have left is the written final exam. Okay. You submitted all your labs basically at this point. I think the last one was firewalls, right? So everyone submitted that. If I've graded everything except like some of you, because of the whole situation, fell behind. So I'll grade those, as soon as I can. All right, so you have the written exam left. You have project A and project B to work on. And then also finally, we have our main focus, which is the VPN lab. Which we're working on. And then the great thing about the VPN lab is actually it's big, right? So it's made up of really two areas, which are the creating the tunnels and routing, tune tap interfaces, right? And that's what we've started to talk about. And then what remains is, if you think about it, you're only building here a clear text tunnel, right? So this is still an unencrypted tunnel. And then to address the crypto part, we're gonna look at, go back to cryptography, basically, like from 350, if you remember in 350, we went as far as SSL, secure sockets layer. But actually here, we're going to talk about TLS SSL, right? And so next on Tuesday, we will do a lecture on TLS, transport layer security, okay? And that will be, the main topic. So once I cover that next week, then you'll be able to focus on the crypto part of the VPN lab. So this is a software lab, and if you remember, it basically has two parts, right? So two problems. The lab actually, oops. Okay, so now the lab here that you're working on, C-Lab, has basically two main tasks. I mean, there's like three really. 1, 2, 3. The first task is what you've been working on, since last week, creating the tunnel. And then the second part will be the TLS part, the crypto. And then after that, things that you can do. So, we can look at, for instance, how to bypass a firewall. So we already did, bypass a firewall already. We did this with the ASA, right? I think it was the very last thing you did before we went online. So the bypass ASA. And we looked at how to do that with SSH and everything. So you created tunnels already. This time around, I mean, it's basically the same thing. Sometimes people use VPN to do this. You see that? And it's exactly the same principle. So for instance, some countries create firewalls, right, that block certain services. And so you can't really access them through the firewall. But if you have a VPN, then you can once again bypass. And so, that's, one of the things. So we can explore that. I mean, that's part of the lab, basically. So anyway, so today and this week, so today really what I want to do is I want to conclude this section, right? So I want to conclude this. And then next week on Tuesday, I'll give you a lecture on TLS just to kind of go over the theory of it a little bit, why is TLS a little bit different, things like that. And then after that, you're going to work on that problem of, making your VPN, add crypto to it. Okay. Remember, at the end of the day now, submission of this will, basically just have one lab left, and you'll submit this, once we're done with it. We're almost out of time with the class. I think we have 2 weeks left, to be honest. So, we don't have much. And then finally, we'll see if time permits. We might do this one. We've already done it, is my opinion. So, in the firewall lab. So we'll see if we complete this one. All right. So, as I said, in the previous video, both of these, so let me write them again. Both of these, tunneling, tunnel, TLS, and bypass. So these two have code, right? So there's code. So I posted it on Blackboard. You can also go to the Seeds website. And in one, you have basically a folder, and it has 2 scripts, right? So there should be 2 scripts. One is for the client, and one is for the server, right? And then on the other end, but these are not encrypted, so they don't have the TLS. So the TLS is not there. And then this one, the TLS one, will once again have client and server, but now this one does include the encryption, right? So the packets now will be somehow encrypted. Now, bear in mind, this is not like a fully, like a really great implementation, but it still should be pretty good for us to see, how this works, basically. Okay. Is this clear, guys?
Yeah.
Okay, great. So how many of you have started working on this lab at this time?
Yeah.
I ran into a couple problems, but I've started.
Yeah, okay. So that's kind of what I wanna know. So you guys have started, but you're encountering some issues, you say. Let me ask you again, I'm kind of, as I would do in the class, right? I would walk to your group and kind of see where you're at. So Tink, Susanna, and Kyle, where are you guys at on this lab at this point?
Stuck, that's where we're at.
Yeah.
Where? On what part of it?
Well, basically, from what I can understand, me and Susanna were able to get to, I think it's step 4 out of the 6, but I don't know what I'm doing wrong, but I can't get I guess I can't get the rest of the tunnel to work right, because it's like it creates the tunnel, the server and the client. You can see that tune is running, but then like if I try to ping from what was it, host U to host V, you're supposed to be able to do that, and to date I cannot do that. And even today, when I actually looked in the book and found this one command that I did not have the first time I tried the lab, it still doesn't work. So I either entered the wrong network information into that command, but I highly doubt I did. I don't know what I'm doing wrong, honestly.
Okay. I will do another, I'll go over this again. Okay, so I just want to get your feedback right now. So let's see. I'm going to pick on
Like to
someone
for the
else.
setup, we have to.
Yeah, go ahead, Susanna, please.
We have to have 2 ports right on the server. One of them is connected to the remote user, and then the other one is connected to the private like EC and inside the network, right?
On
So
which machine are you talking about?
on the inside of the network.
She's
So
talking.
you're, the 192. So you're talking about. So let me. I guess. Let me do this. So. So you're saying you have this, right? And then you have this, and then you have this, and this, correct? So this is U, V, and this is the server, and this is the client.
Correct.
Okay, so where are you having the problem?
Right, so you have to have like 2 ports to say from the client to the server, and then another one connected from V to the server, right?
You have an IP address here, right?
Yes.
Then you have here the tune tap enabled. You open, basically imagine that you just open, just like this is a NIC card, right? A network.
Yes.
That you just open this one, and this is a virtual one. So it's not a port. It's itself an interface. So that when you do if config, it shows as an interface.
Okay, so when you first start off, can they all ping then? Is that okay?
When you start?
When you first start, yes.
You can only ping with, in the VPN once everything is established.
No, when you first start,
are you talking about like if I'm here and this one, can I ping it? Is that your question?
Okay, when you first create all your 3 VMs, right? Since they're all in the same network, they can all ping, right? Or are you supposed to create
I'm sorry. So here, 10.0.2.8. These 2 be able to ping? They should.
Yeah.
Yes.
0, 2. You see that? They should be because they're in the same network, right? They're in that network. This, in fact, what's happening here is exactly every single setup you've ever had in VMware. So they can ping for sure.
Yes.
Okay. So then now maybe you mean on this side. So you mean
correct.
This one is 1, 2, let's say I'm just making 168. These might be the numbers. On this 101 V. And then this interface over here is 192.168.60.102. Okay. All right. So ask your question again, please.
Okay. So the question is, how do you have to create another adapter here and ping to how do you set that IP into that adapter? That's what we're.
In which one? Which one?
In the server.
This one. So, okay, you have to create, I think I understand. So this is a NAT creation in the editor. So in VMware, when you go to VMware.
Yeah, actually the first one you don't have to worry about because it's already set on that.
Right.
them.
Right,
It's the
right.
second one.
Right. And then this one over here, also in the VMware editor, is like a host network.
Only. Is it a host only?
Yeah, host only. There's only 3 options. There's bridge, NAT, and host. Yes.
Okay.
So that one would be host, and then this machine, they will be connected basically. Right? They will be connected.
Oh, I think you may have just helped solve part of my problem because I had.
The other thing is make sure you can, because this is acting as a router. So make sure you enable the forwarding parameter there. There's a little forwarding parameter there.
Oh yeah. I made sure that the server ran that command and the client does because they both need to run that. I even put that in on the host V, just I don't know, just in case it needed it. I think you might have helped solve part of my problem because when I set up the client and the server, I had it on and I use VirtualBox. I had it on what was it? Network, not like just plain NAT, but like NAT network, like the one that you specify yourself.
So you're saying this one was also on NAT?
No, just the server, like the 10.0.28 and the 10.0.27. I had on NAT network, which is one where you specify it yourself. Is it supposed to be on the general NAT where it's just NAT, you don't specify anything?
This one?
Like, are the client and the server supposed to be on just NAT? You don't change anything, it's just NAT.
Yeah, I would do that, yes.
All right, I can try that next time.
Because they will already be on NAT anyway, right? So
Yeah, when you first start off,
it's really your only problem is this. And so it's, you need to connect it. And actually this happened a lot this semester. Remember that you guys had that problem that your physical machine was not talking to your VM?
Yeah.
Remember that? That happened quite a bit. And it's actually because that wasn't there. So you guys kept going to the editor and then you needed to add that and then you created that and then now it worked.
Yeah. I remember that.
Where I'm having an issue. I can't get it to work.
You can't get it to work? It's not? Okay. All right.
I added the adapter and
we can take a look at that.
So hard to do.
Your screenshots and things like that, or your Zoom sharing. But okay, it sounds like you're making good progress on this. Okay. So let me just ask other groups where they're at, guys.
Okay.
Yeah, and then we'll come back. Okay.
Okay.
All right. So guys, so like I said, today we're doing this kind of a lab session like this. So hope this is so anyway, so let's see. Si Hao Fang, Jadong, and Daniel, correct?
Yes, sir.
Where are you guys at on this lab?
We really haven't been working it together. I don't know where they're at. I have an idea.
They can speak, right? I mean, so they can feel free to say something, guys.
Where are you guys at? Zihao and Shadong?
Yeah.
Here, let me share my screen.
The Falwell?
Jingdao, are you able to talk? Professor, may I share my screen?
You can share.
It says I cannot share while the other participant is sharing.
Oh, you can't? Okay, so I have to stop sharing mine, you mean?
I believe so.
Okay, hold on. Okay, try now.
Okay. All right, let me just get the right screen. All right, there we go. Okay. So just to make sure I've got all this.
Just bear in mind, this is being recorded, right, Daniel? So just...
That's perfectly fine. So I'm using VMware Workstation.
Yes.
My network settings are host only between this one as one network, 10.02 network, and this one's the 10.06 network, and VM1, VM2. Is it too small or?
It's a bit small, yeah, but
Sorry, 2K monitor, all that. At least it's on the 2K, not the 4K. Okay, but it is VMnet 1. We have 10.0.2.0, just like what it's showing on the initial settings of the network, the 10.0.2, and then the 60, 192.168.60. And so VMnet 1 host only is the 10.0.2 network. VMnet host only is the 192.168.60 network. And I've got it throwing DHCPs and all that sort of stuff.
Okay.
And so that's my network settings. On each of the devices, I've got Ubuntu 1, Ubuntu 2, Ubuntu 3. I actually think I only need 2 of them. And I had it set up for another lab. But it's been a week since I looked at this, and I've been working on other ones. But I set these networks up to where each of them has 2 network ports. But, oh, that's what it was. It was, and now I'm mixing up. So we have, oh yeah, we do need 3 systems. So you've got your VPN system, your gateway, and then your other client. So the way I set it up is that Ubuntu 1 is connected to, let's see, settings. It's connected to like the first VMnet 1. Where'd it go? There it is. Okay, so adapter 1, VMnet 1, it's connected, powered on, and it's VMnet 1, host only. VMnet 2 is disconnected and powered off. So we're not getting any service on that one. And so that's the difference between ENS33 and ENS38. 33 is the one we're working with on the 10.0.2 network. Then the Ubuntu 2.
Is that the server? Which one's
Yes.
Okay.
This one would be the server. And so it's got, I think what it was is I set and copied it, just copied from one to the other. And so this one's got ENS33. It's on the 10.6.0 network, and ENS38 is on the 10.0.2 network. So this
the NAT
is
network. The NAT network, right?
Well, they're technically both of them are NAT networks.
Okay, got it.
Do I need to give them access to?
No, I mean if it works, it works.
Okay, and for me, as long as I don't have to apt-get anything, this should be fine.
Okay.
Anyway, so I've got the Ubuntu 2 working as a server. It's got the routing and everything working through there.
And the forwarding and everything.
Yes, and it's been a while since. I don't remember if it's in this user or what, but oh, okay, maybe I did it on a root. Yeah, come on. Okay, well, maybe I didn't do it on this one.
Okay.
Okay, so here is the Ubuntu 3, which is using
the host V.
Yeah, it's also host V. This is the 192.168.60, and for some reason I've got it on network adapter 2, but no big deal. It's on there, and so I've got these 2. When I ended up running the software that we had.
So Daniel, before you run the code, right? Just like we did a lot of time in the physical network when we had our Cisco equipment, you ping, right? Remember, you would ping, can I access this one? Can I access that one? You remember that?
Okay.
So my point is, if you're gonna VPN and forward packets from host 2 to host V, right? That basically means that first you wanna see how the ping works.
So I cannot ping.
Okay, so did you try pinging anything in there? Because my point is that if you try with the pings, you can do things like, oh, I need to disable the firewall on these things.
Okay.
You know what I mean? If you might implement your code and you run and then you forget, oh, I never put the firewall in, or I never did the forwarding at this section, or remember the very common mistake that everyone made this semester. You always forgot to put gateways on the devices.
Okay.
Guys, does that make sense? Daniel.
Yes, sir.
Yeah, so that's that's the first thing I would do before you even start to really worry about, because if you can't ping, you know, like at least with the same network, you know, other things may not work either, right?
True.
So, okay. Now, what do you?
I think when I set everything for static, it doesn't work. Whereas when I set everything for
you're also using
then
the,
it
I
works.
see. Okay, so that's problematic, Daniel, because you might assign the wrong gateway, or you might assign you need to probably, just like we did in the class itself when we were in the lab, probably want to set these statically.
Okay. But it seems whenever I set it to static, then I have no communication between the two systems.
Yeah, so exactly. So that's what you need to get working first, right? So, you know, that would be my suggestion. Set everything statically to manual. And then, for instance, if it's 192.168.60.101, what should be the gateway for that?
6101 should be 60.1.
Exactly. What about if you're on the interface 192.168.60.1? What should be the gateway for that? Technically,
I believe it'd be 10.028.
Nope. See, this is what I'm talking. No.
So it's the 192.168.60.1.
Sorry,
the gateway.
I missed that. Sorry.
So the 192.168.60.1 would be the gateway.
Yes, its own self would be.
Okay.
It's own self, yeah.
Gotcha.
Yeah.
Okay.
What was that, Susanna? I'm sorry.
I said its own self. That's what it was supposed to be.
Its own self, exactly.
And that's what I tried doing, and I was really frustrated because I connected I thought I connected everything, and then I just tried to ping from the vhost to the actual server, and it wouldn't work. I mean, since the other two are on the same network, they were able to ping, but I just couldn't get the vhost to
okay, so your problem is that you're, let's say, on host V 192.168.60.101, and you're trying to ping the interface 192.168.60.1.
Yes.
Okay, and that's not working. Okay. So you've configured gateways on both.
I don't have it right now, but
you don't. Sorry.
I don't have anything up right now, but yeah.
But it shouldn't matter, you're saying, right? And then the mask is the same, I assume, right? They're statically set. There's no firewalls.
And I disabled the firewalls before I started anything.
Both, yeah. So I would say it's something, you know, without looking at it, I would say it's probably something with your in the VMware editor. Somewhere in there that can that might be the issue.
Yeah.
Because once that's established, it's basically like they're connected to the same switch. So at the end of the day there, all you would need is firewalls off, IP addresses in the same network, same subnet mask, you know, appropriate gateways, and that should be it. Set the manual. Now, one thing that you could try is what Daniel said he tried. There's one called manual without setting the gateway, I think, or is it the DNS server? I can't remember, but you could try and just see what that does. First of all, what IPs it gives you.
I mean, I know that the server had to be itself, like its own. You know what I mean? Like
I'm sorry, I missed that. What did you say?
I knew that the gateway for the server was itself, like the 192.168.60.1.
For server, yeah, okay.
But I just didn't. I just couldn't get the other one to work, and I was just.
No, that makes sense. I mean, right now, you know, it's just like with the physical network, right? You know, they're both on the same switch, so you want to see if you can. Now, I'll ask you this question. Did you try to ping from 10.027 to 10.028?
Yes, that worked. Because they're on the same network. So yeah, I know that was working. I just couldn't get the
okay.
Yeah, that's the only thing I couldn't get to work.
Okay, all right. Let me think about it. See if I can think of another idea. I mean, that's basically what I would do. I think it's possible that it's in the editor. in the VMware editor section. You know what I mean? Like when
Yes.
up there, it could be there. That could be the problem.
Yeah, I kind of messed with it for a while, but yeah, okay.
Okay, all right. So let me go around, see what other people have done, right? So let's do that for now. All right, so Neil, Bus, Trevor, Evan, are still there?
Hello. Yeah,
Neil? Okay,
we
Neil.
haven't started it yet, so we're.
Oh, you
we're a
haven't
little-
started this? Okay.
Yeah, we're a little bit behind, but we'll catch on it.
That's all right. Okay. All right. Okay.
Professor, I got a question while we're on this.
Yeah, then.
I don't see where you set a gateway on the VMware. Maybe I should share my screen.
Okay. Here, you can set a gateway. Let's say, can you bring you have that little diagram? Yeah. If
Are you on this one?
Right. So each machine needs to have a gateway, right? So let me put it this way. Each interface needs to have a gateway.
Okay.
For instance, in the 10027, if you go, you don't see the gateways in the editor. You set it in the upper right-hand corner.
Yes.
You have
Yes.
the two
There.
little arrows pointing up and down.
On right on your right side. Yeah, there.
And then you edit connection. And then you have all of these. So you need to pick the interface that is for that IP, IPv4. And then, yeah, manual, add.
See, I understand how to do this. This isn't a problem. The problem is when I set this, I don't have any connectivity between my machines. When I set static on here, I get no connectivity between the machines. However, I run everything DHCP, then I can bump the two machines, but then I don't have any control over the gateway, which to me would be in here.
No, it's not there. This is just for like, it's, I usually think of this as just setting up the switch. So you want the DHCP here to serve the
That seems to be the only way that I can get connectivity and talk between the two systems, or any of the systems together.
Well, what I can tell you, Daniel, is that you will need to have a gateway for this to work. And it should, the easiest thing that I would think of is just setting it on the thing I just showed you, the two arrows.
Okay, so just a static.
Yes, yes. Just like we've been doing all semester, static should work, right? So.
Okay, well, I'll make something happen.
All right, so let me see other groups. Yeah, you can. Yeah, thanks. So let's see. Shang-Chi, Alicia, and Jackie. Can you guys hear me?
Yeah, I can hear you.
Okay,
Yeah.
have you guys started working on the VPN lab?
I think I just finished the first two tasks. I'm doing the task 3 encrypting the tunnel by the TLS.
Okay, so you're telling me that you already created the tunnel, the clear text one, and that worked. You're just now moving on to the TLS part, right? That's what you said? Okay. All right, so good. So you're making progress, so that sounds pretty good. Let's see. I already asked Trevor. Okay, there's some, Parker, Newman, Luis, and who else is in your group, guys? Parker? Can you hear me, Parker? Okay, so he's there. Okay, Wen Liang Chen, Shashing Shen, and Sing Lee. Can you guys hear me?
Yeah.
Okay, great. Let me actually, I can share my screen now, I think. Okay. So where are you guys on this lab? Guys, can you still hear me?
Yeah. We almost done the test one, and we are trying to figure out test.
You're trying to what, sorry? Sing?
We almost finished the test one.
Which is what? Creating the tunnel?
Yeah.
Okay, there's a part there to sending a, like a ping packet or something through the tunnel. You were able to do that?
Yes, and we are trying to.
I'm sorry, what was that? You were trying to what? Wen Liang, are you guys still there? Xiaxing?
Yeah. Also, so right now for test 2, we are trying to use TLS encryption to encrypt the traffic.
Okay, so you've completed the tunneling part. Now you're just trying to add the TLS code, basically, right?
Yeah. Basically.
Okay, all right, sounds good. Let's see. Is that every group, guys? Did I miss anyone that's connected here?
I think that's everybody.
Oh, okay. All right. All right. So that's everyone that's here. I see Parker's here, but he never replied. Okay. All right. So, yeah, so I would say, kind of to summarize, setting this up first, right? So setting this up first, I would just say statically, you need to use the VMware editor, right? Don't forget to set the gateways on all of these statically. And then after that, you have to ping, make sure there's some connectivity. And then after that, you want to do through the VPN, right? So through the VPN. Remember that once you actually, so let me say this. So I know I said disable the firewall here and everything, right? But after you know that there's connectivity, and once you want to test the VPN, so at that point, this once again should become a firewall, right? So this should become the ASA, let's say, again. So that means basically now any traffic coming from here, right, coming from here to all the way in here will not be allowed anymore. It will not be allowed anymore, right, at that point. And so at that point then, that's where you have to then add routing rules and the tune tap, which will serve for the routing rules to actually create the VPN tunnel. Once the VPN tunnel is established, then at that point, you should be able to, then to, ping and use telnet all the way from here to here. You guys, does that make sense? Susanna?
Yes.
Yeah, okay, all right. So that's important. Like I said, I know initially I just said, think of this one as a router, but then after that, you kind of need, once again, to think of it as a firewall. And then, yes, after that, once this is basically like a firewall, access is denied here. And that's where the VPN comes in to let you access your information. Okay?
Okay.
All right. So let me go over then. I want to give you now an overview of this. We've had some questions about it. So let me give you a kind of an overview of this. And then I guess we will, we'll need to zero in on your specific problems. So I know I had covered some of this last week, so I just want to, I left off All right, so one thing that's going to happen when you run your code is that you would, let's say you do sudo /tune demo, right? Or whatever your code is called. Does this print out something that says tune file descriptor, and then it gives it a number? Do you guys see that information? Guys?
I never have.
You never have?
All I see is something like got a packet from the tunnel or got a packet from Tune, something like that.
But when you send a packet? Or without sending traffic?
It kind of seemed like with or without sending traffic. Like if I was trying to ping between machines, like if I use the server to ping something, like sometimes I'd get, got a packet from Tune or got a packet from the tunnel or something like that.
Okay. All right. So that's only all the information you get, you're saying?
Yeah, those are the messages. I've never seen something like tune file descriptor equals.
Okay, so this might be something that's in the code then that you have to print out intentionally. But when you print out a file descriptor, what I want to say is let's see. Someone answered here. Mine was like that at one point when I configured host only network, so I set the server. Didn't help. Okay. All right. So basically what I'm trying to say, so let me just go over this. So what is happening behind the scenes, is that TuneTap is, it's a virtual interface, right? But that virtual interface is really like a file. You can think of it as a file. Let's call it file descriptor number 3. All right, so you create an entity in memory, and it's basically the end of the tunnel. All right, so if it's called, let's say, file descriptor 3 or some file, then you can reference that tunnel as well to test your connection, right, between both ends of the tunnel TuneTap. So you could do, for instance, something like this. You can say, which if you remember, this is just a redirection, right? And then you can take 3, which is the file descriptor. And now what this means is that, let's say you have the computer here, the computer has a TuneTap. Anything that hits that TuneTap, anything that hits it, it's basically like it's hitting this 3. So it's coming here, and now you can pipe that information into whatever you want over here. So for instance, a packet is probably coming in as binary, right? So the actual data that's coming in is binary, the packet, right? So the packet, the actual data that's coming in it is binary. And so if it comes from the descriptor 3, because in Linux, pretty much everything is a file, so you can reference it as this, as a variable, and redirect it. And then you could troubleshoot this. For instance, if you wanted to view the packet, you could do xxd, and this program will converts something to hex, right? So then you would be able to basically see it as a hexadecimal. And it works the other way around, right? So if you had, let's say that you have a packet, you have a packet file, right? And you want to send it in the tunnel. Well, first of all, I don't know how you have the packet, right? So let's say you have it in plain text or you have it in hex. So if you have the packet in hex, you will have to run it through the XSD program, and then now you can redirect it into 3, the file descriptor. And what that will do is it'll take, so it's now like from the program itself, the packet is now being sent to the TuneTap, and from there it'll go through the tunnel. Do you guys see that, guys? So what I'm trying to say here is that TuneTap, whenever you create TuneTap, right, that, that interface, you're also creating a file descriptor, which is currently, possibly not printing because in your code it's there, but it's not, it's not enabled to print. But once you, let's say you print whatever that descriptor is, you can reference it from, this is the command line, right? So from the command line, you can reference it, and then all you have to do is use redirection to move the packet. So you can move the packet, from in that direction, or you can change the redirection as such, and then it would go in that direction. So that's another way that you can interact with this interface. Okay. Does that make sense, guys? Guys? So you have, TuneTap defines a file descriptor 3, and then this file descriptor is tied to whatever program you have, right? But you can also reference it from the command line. Okay, so you can do that, or you can do this, okay? And so that's one way to interact with the TuneTap, for instance. So let's look at another example here. Let's say that you do have a hex, you have a packet in hex format, right? So you have one single packet in hex format, and you call the file hexfile.txt, okay? So now if you want to send that, okay, if you wanted to send that, how could you do it? Well, you could do xxd, right, -r hex file. Remember that this will convert a hex to binary, right? So when you do this command, when you do this command here, you're basically converting your packet, which is in hex format, and now you're converting it into binary format. And at that point, then you can send it into the tunnel, right? So you can do something like this, right? And then all you need to have is the file descriptor, and this will send it to TuneTap. So it's really like, then it'll go to, to the TuneTap here. And once again, it'll enter the tunnel to arrive at the other end. Okay, so that's how it works basically. TuneTap is a, let's think of it as a file or variable in memory in the operating system, and then through the command line, you can reference it as long as it's open. One thing you can always do, so one thing for troubleshooting, I know you guys had a lot of questions about troubleshooting. One thing that could help you out is Wireshark. Okay, so have Wireshark open whenever you're sending this, right? So have Wireshark open on both ends and figure out, at what point you're just not seeing the packets, right? So is the packet just not leaving the machine, or is the packet, when you open the packet and you look at the parameters, maybe you can see something there about the IP address, etc. Okay, so that's definitely a recommendation I would give you. Open up Wireshark. Okay, we talked about, we're doing this lab on top of UDP, even though it can carry TCP. So we did talk about that. Okay, so we talked about that. did you guys give your let's see, so I have a question. When you guys did the host, or so the network between, for those of you that are having issues, when you did the adapter for the 192.168.60.0 network, right? When you did that, did you have to configure on the editor, something like, okay, this is the 192.168.60.024 network? Guys?
Yes.
Okay. All right. So you did that, right, Daniel?
Yes, and I finally got it to where everything's pinging each other.
Oh, you got it to work now.
Yep.
Okay. All right. Good.
How on earth did you do that, Daniel? You'll have to send me what you got.
I guess I should have left the screen on so everybody could saw, but it was just, like I said, it was my local system. My host system was taking up the 192.168.60.1 IP. Once I figured that out, I went into the network settings for that adapter on the host system, changed it to another IP, and then that freed up that IP, and I was good to go.
Yeah, well.
So you had a clash of IPs? Is that what you just said, I think?
Yeah, for some reason, VMware automatically set the local host.
Oh, that makes sense. You had in your network 2 IPs, maybe it went to the other one, right?
Yep, and that's what the problem was, a conflict.
That makes sense. Actually, that could be it's like a mysterious problem, but yeah, that could be the issue. Good job.
Thank you.
Let's see. So I just really want to wrap up all the notes that are relevant for this. And then, all right, so we talked about monitoring the file descriptor. So we talked about making one of the VMs, remember, you're making it into a router, that gateway machine, okay, with IP forwarding. And you guys know the command for that, correct? That's just, so for IP forwarding, this would be on server, correct? Everyone? All right, and so the command for that should be...
It's on page 4
of
the VPN file that you sent us on the learning.
Yeah, CTL -w net IPv4 IP forward. So you only need to do this on the server, nowhere else.
No, that doesn't.
Or on the client. Oh, actually on the client too, right? You have to do it on the client too as well, right?
No, I don't think on the client. No, this is just the center computer. The server. I'm sorry, the routing computer is all that needs that.
Okay.
From what I understand. Now,
-w
we don't have on page 4. Is that on a different page? Or what is the -w?
Well, let me put it this way, Daniel. It's something to think about if you have to also do forwarding on the VPN client. And the reason why I'm saying this is that remember that just for the sake of simplification, VPN client is not acting like a router. So basically what you're saying there is that same machine is both VPN client and the host U. So I guess what I'm saying is, in a real network, you would have had something like this. Make sense? But to simplify this lab, this one is all being done on the same machine. Daniel?
Okay. U. What's the U?
U is this one, so they're both the same. So this one, VPN client and U are the same.
Okay.
But in theory, or in practical sense, they would have been separate machines. So this would have been like VPN client, VPN server, right?
Okay.
And this is a separate V, and this is a separate U.
For like a separate system on a separate node on each one of the networks?
Yes, exactly. It would have been, this would have been a network, and this is another network, and this
Oh yeah, like on the VPN server side, clients can access
Yes, exactly.
what's on your network, and you can
Yep.
access what's
You're
on
in
yours.
someone's
Yes.
house and then someone's house, right? And then you have your router and then you have your router and then you're behind it. U and V, correct?
Yep, and they can put stuff on your
So
your
in
TV or
theory,
whatever.
that's how it would be. This lab doesn't do that just for the sake of simplification.
Yes, thank you.
However, that being said, keep in mind that when you are, just like here, when you're VPN and you need to forward, you may also need to forward here, even though you're forwarding within your own self. So just be aware of that. That's all I'm saying. Keep
Yeah,
that as
normally
a,
set that on the VPN server.
for now,
and on
set
the
it only on
client.
the VPN, but think about it a little bit.
Is the IP forwarding being enabled on the client as well, so we ensure that it's directing those packets to the tune interface?
Yes, actually, that's probably,
Because I know that that's kind of the insight on it for the server, and I know that we do. There was one command on the PDF provided. I know in the book it has it too, but we also do. I believe there's a command for like IP routing.
okay.
Let's see.
The
Or
route.
sudo route add net, and
Yeah.
it's for an array of different networks to ensure that the 192.168.60.0 directs those correctly. And I don't. It says on both client and servers we need to set up the routing entry, and I think.
Okay, so you're saying that you found somewhere in the notes that it does say set routing on both VPN.
Well, what it details is that it's ensuring that the routing is sending the traffic to the tune interface, I believe, on both the client and server.
Yeah.
And
Yes.
I don't know, it also mentions that it might already be added when you set up the tune interface.
Okay.
But I guess a way to kind of compensate and make sure that everything works properly is to set up that enable IP forwarding on both client and server.
Right, just do it anyway, right? It shouldn't.
Yeah, that's what I'm
anything.
figuring.
Yeah, okay, that sounds about right. And so what I would say is the way to think about it is that really it should have been like this. Okay, but just for simplification sakes, everything is done on just the same machine. Got it, guys? They both still have tune tabs. Okay, that's not what I'm saying.
Yeah,
They still have
definitely.
them. It's just that it's like two that would have been here have been now shrunken into just one. And only for simplification's sake. All right?
You know what I find very interesting is that
yes, sir.
One of the times I ran this lab, I was able to ping from the two tune interfaces. So like if I was on the server and I pinged the client by its tune interface as opposed to its normal IP address, I was able to ping back and forth either side. It didn't matter. But then at some point...
Well, that tells me that if you were able to do that on the VPN network, you set the tunnel somehow correctly, but maybe you had other issues with your routing.
Well, it's just, what's weird is that like at one point I got that working, so I thought like, oh, I should be good to go. And so I thought like, oh, okay, let's just do host V and whatnot. And then that didn't work. And so I'm like, well, maybe I don't have it right. And then at some point, I think during the same run of the lab that I was doing, I had ping traffic between the client and server using their tune interfaces. And then, well, I lost it just as quickly. So it's like, I don't know.
Okay. Well, I mean, the tune, both tune zeros, I think in your book, or they're all on the 10, what is it, 420 network, guys?
Well, actually, the lab report has you putting the tune interfaces to, what was it, 192.168.53.0.
Oh, really? What is it, 192?
168.
Okay.
53.0.
Okay. All right. So it, like I said, I mean, you know, from here to here, this works, right? So this, you know, this is established. Then the tune tab goes through here, right? So what you're telling me is that you were able to establish the tunnel and then you got all of this right, but possibly, I think if I understood you, it wasn't getting that far. So you just, it sounds like a routing issue here. Okay.
So the, let's see.
Who is this?
You were mentioning
Nathan?
yeah, this is Nathan. You were mentioning the file descriptor. I think it was like the
Yes.
XXD and rerouting that. So that's to write to the tune interface, correct?
That is correct, sir.
Okay.
What I was saying is, remember that in Linux, everything is a file.
Yeah.
Pretty much. So even interfaces are files. Even your printer is a file, everything.
Mm-hmm.
So why not a network card be a file? And therefore also a virtual network card such as TuneTap is a file. And it can have what is called a file descriptor. So some kind of a number, right? And so once you reference that number, just like, you know, obviously it has to be on, but you can then reference it. So every time you want to touch the tunnel, it's 3 here.
Yeah. Okay.
And then
now,
there,
you can observe that with Wireshark as well. It will show you can observe that with Wireshark, you were saying as well. Like say when you touch or write to that interface, it will appear because it's being written to that virtual network card.
Yes, but what's important is, remember, this is a tunnel that expects UDP packets, right?
Correct.
So basically, what's important is it expects packets.
Okay.
So what you send there, I don't think you can just say like echo hello. You know, it's not a packet. Is my point.
Okay.
But what needs to go into that tunnel is an actual proper packet.
And that's I'm assuming why. Now I'd have to look back into some of the lab work, but that's why it's done as like a hex dump or a hex file.
Exactly right. So exactly. So what I said is, if I have a packet, you know, and the packet is, you know, like I have a hex packet. Even if it's a hex packet, you still need to use that command, something like XXD.
Okay.
Convert that packet into binary, because it needs to be a proper packet as you would send it in the network itself.
Okay.
So you're getting, it's like you have a file descriptor to the network card, but you can only insert in the network card actual packets. Do you understand?
And then once you have that successful, it should, in theory, with the IP forwarding, if done correctly, it should go to the other side of the tunnel or the
That's right. If you've done the forwarding and you have all the routing rules correctly, okay. So I think I understand your question. So let me see.
Because I believe, like what I think Kyle was mentioning, I'm just getting to the point where I'm setting up the VPN tunnel and configuring all the routing, and I want to make sure that once I have that, I can have something to observe to see if everything's working right with the tune interface.
Right. So all right. So when you build, you have your physical machine here, right? Your physical machine. And then you have the computer, and then it creates the TuneTap.
I don't know if it's showing your screen at the moment, just to let you know.
It's not. Oh, I'm sorry.
No, you're fine. I don't know if it got disabled or something on mine. I want to make sure.
No, I probably need to share it. Hold on.
Can I interject a question here?
Give me a sec.
Okay.
Daniel.
We're seeing your screen now.
Yeah. Okay. So let me just finish this thought with.
That's fine. Go ahead.
Nathan, right? So remember, TuneTap is a way for you to have code, a program, right? And from that program, this is the TuneTap. So a tune tap is an interface, a virtual interface between the physical computer, the physical network, and some program. You see that? And then over here on the other end, you have the other physical network card, a tune tap, and then over here you have, another program. Do you see that?
Mhm.
That's what the tune tap does. Now, additionally to that, a tune tap can just be, it doesn't, like need to be linked to a program itself. It can just be a file descriptor.
Okay.
And if it's a file descriptor, let's say 3, and then on this end, it's a file descriptor 3, it is basically an entity in Linux, right? Like, it's a file, this thing.
Yeah, the Unix way kind of idea.
The Unix way, exactly.
Absolutely.
Exactly right, the Unix way. So you still have the physical here. You have the file descriptor over here, file descriptor over here. They're linked. And then now, instead of just writing code, if you want to just like test this really quickly, right, you can just go to the command line, right? And as long as you have that file descriptor, you can direct things into it. And so over here on this end, I guess you would do, like this. And then here maybe my own text file, right?
Mm-hmm.
Do you see that, Nathan?
Yeah. No, and
some input here would be a packet.
Okay. And that would be the binary whatever compilation.
Right, exactly. So this is still a network. So basically the binary version of a packet. So it's not like, you can just send anything in it.
Yeah.
In the format of a networking packet.
In the example you give, it could, you could put anything to that file descriptor, but in this instance, it's the binary data for the packet.
That's right. It's the binary data. Yes. But you can always like convert things, right? So there are ways of converting things. Let me see. I know I saw an example. So I wonder, so if you do like like just sending one packet, for instance, you guys had that Python code, right? So you'd have to link it somehow. So let's see. You can try, as long as you have the routing also, what you could probably do is, once you have the correct routing, you can ping to that, right? And then ping on one side maybe. And then on the other end, you're going to get a packet that you could save in a text file. So you could try to do that.
Yeah. And then once you have that packet, maybe,
and then once you have that packet, you can now use that packet to play around with it.
Okay.
Because the problem is creating a packet that's binary, right? So that's going to be a bit difficult. But if you probably ping the interface directly and you get a packet to come out, you can see it on the other end. You just print it out.
Okay. Yeah. And once again, that's a good example too. I just want to have something to visualize so that, I confirm I'm doing this correct.
In my opinion, that would be the way to visualize that you got to.
Okay. Excellent. Yeah. And I know that the XXD, that's for specifically the hex dump, right? That's
the
what converts
XSD
it.
is because if you don't use that XSD, you're going to get a binary thing.
That's okay.
And so you want to, at least with a hex, like in 450, right? We had all those, like 43.9E and all, OC.
Yeah.
Look like that.
Okay.
And so that will be a little bit more readable. I'm sure there's other commands that would you to visualize it. But that's how you know that you got the packet at the other end of the tunnel.
Okay. All right, that's good to know. Yeah, I unfortunately got into this a little bit later, so I'm just clarifying. So thank you, I appreciate it.
Okay, sure.
I know Daniel had a question. I don't want to.
Oh yes, I'm sorry, Daniel.
Take up all that time.
What is your question, sir?
I'm looking at what I did last time, and
Yeah.
it looks like I was trying to set up the server on the unit in the middle, the router. That's incorrect. It should be on the inside 192.168.60.101 system. Is that correct?
Let me see. I don't have the diagram in front of me. Hold on.
Here, I'll show you what I'm talking about if you want me to share.
Yeah, can you share it, please?
As soon as you
Oh yeah, sorry.
yeah, stop sharing.
Go ahead.
Okay. All right, so you're looking at this screen here?
Yes.
Okay, perfect. Okay, so it looks like when I originally ran everything with, aside from my other problem, that I was trying to run the client here, and I was trying to run the server, the VPN server on my routing system. That's not the way to do it, is it? Because it looks like it's got the internet.
The client VPN should be on the client VPN machine, and
the server should be on,
in the machine that's routing. So no, you have it right.
So it should be on this machine.
Yeah, go to
here.
this diagram. That diagram is pretty good.
Okay, so this system here.
That's where you would run the VPN server code. Yeah.
Okay, so I was doing it right. Okay.
Yeah, no, that's where you would run the VPN server code, and then on the other end, it's, remember these, those are the two like site to site, right? So that's the site VPN that you're building.
Okay. Okay, I needed to clarify that because I'm like, wait.
The host V is just some laptop, some regular machine that's connected in the network.
Okay, so I want to run it on my routing machine and my client on the outside. Okay, got it.
Yes, sir.
Thank you.
So let's see. We still have some time. So let me. I need to share my screen. Okay, so kind of wrap up some of the ideas we've talked about. So you want to configure VPN server. You want to configure VPN server. So what do? Run. It's kind of what Daniel was saying, but run server program. Right? You will need to create the tune interface. So what is it? Bring up or turn on, enable tune interface, right? Tune tab. Interface, okay. Then you want to configure it, right? So you want to configure it. So what do you do there? You do some kind of a if config tune 0, and then the network that the IP address that you're going to assign to it. So I'm just assuming that's the IP 24 up. So this is what you guys have done, correct?
Correct.
Correct. Just did it. Sorry.
Yeah. Now you need a route there. This is on VPN server, sudo route add -net, and then you're going to say when something is going to the network 10.4.2.0.24, which network is that? Right, that's the tune network, right? So if you want to go there, you forward things to tune 0. Make sense?
And
so we want to send it to tune 0 instead of etho 0 or any other network.
Well, you want to forward. So if it's, so this is saying that if something is going to that network, something is headed to that, it should enter the tunnel 0. right? So it's basically any VPN. So it's like something came from a VPN request, entered your network, and now you're replying back, right? So it needs to go back to the other end of that VPN. So it needs to know that if anything wants to get back into that network, it goes into the tunnel 0. Does that make sense, Daniel?
I'm kind of confused here. The page 5 sudo root add -net 10.20.30.0. That's just a number out of nowhere, going nowhere.
Is that in the book or in my notes?
It's in your PDF file, the VPN PDF.
Yeah.
I have to figure out what.
So I think in the PDF it shows. I think it says it shows how to route packets bound for the example network they give on the ETH0 or Ethernet 0 interface. Whereas this example is showing like what Professor Calix has written. This is showing how to route it to the tune interface, or the one he has at least determined in step 3 in this slide. The one on the PDF is a little bit different, and it's not to the tune interface in the example.
It's not?
Okay, it says sudo route add -net 10.20.30.0/24 to ETH0 ETH0. So I think
I'm bringing up that PDF right now.
Oh no, that's no problem.
Give me a sec.
Okay.
So if I'm understanding it correctly, we
Give
need
me a
to
sec,
do
Dan.
the
Let me
60.
look at what you guys are looking at.
Okay.
All right, so.
Oh, not you. There you go. Sorry.
Okay, so you're looking at the PDF.
I think it's the first code on page 5. The first code highlighted in gray is the example of the command.
All right, so page 5. Oh, okay, so setting up. So it says there, step 3, set up routing on client and server VMs, right?
Mm-hmm. That's the one. Yep.
Okay, after the above steps, a tunnel will be established. Before we can use the tunnel, we need to set up routing paths on both client and server machines to the private network 192.168.60.0.24 towards the Tune 0 interface, from where the packets can be forwarded through the VPN tunnel. We will not be able to access the private network at all. And use the route command to add a routing entry. The following example shows how to route the 10.20.30 network bound packets to the interface ETH0. On both client and server machines, we also need to set up a routing entry so all the traffic going to the 192.168.53.24 network are directed to Tune 0. This entry will usually be automatically added when you assign. Okay. So no.
I think the only difference from what I can tell for at least the server, for the command that's shown there, we would just do sudo route add inet, or excuse me, -net, and it would just be 10.0.8.0/24, and then the interface we want, which is Tune 0, correct?
Yeah, I mean, I don't understand that ETH0. That's why, let me see the.
Yeah, that example is weird that they give that, but I think according to our network, it would just be the 10.0.8.0.
Let me see. So the Tune network for this diagram is 10.0.20. And here it says 10.20.30. What is that 10, 20, 30?
It doesn't make sense to me. It's almost like they're giving an example to lead you off, but they don't use that number anywhere before.
Okay, yeah. So, okay, I see what you're saying. What you're saying is PDF has some kind of, okay. Yeah, I don't see that 10, 20, 30, to be honest, either. $192, 6853. That is 20. Saying the following example shows how to route the. That may just be an example, guys. That may not be that they're saying that you actually have to use that. If you read it, it just says the following example shows how to route the 10, 20, 30 bound packets to the interface ETH0. But what I would say is your entry should be based on your network, right? That may just be showing the way the command is written. Unless someone else has found that network. Does that make sense, Nathan and Daniel? Guys, are you still there?
It kind of does, but it's like almost like they're sending us off after a snipe.
I mean, just follow. How about you just follow the instructions I was giving you? So just, configure the VPN server like this, configure the VPN client like that, and, try that.
You can check the route you've established, correct?
Yeah, pseudo route.
Okay, yeah. So that shouldn't be any trouble. At least, we can experiment with the command.
Yeah, if you don't have a 10, 20, 30 network, I mean, think about it. So think about it. Think about it this way. If you don't have that network, I mean, it's never going to go there, correct?
Yeah, no, absolutely.
So
now I've got everything set up the way it's showing. I threw that one in with my network. I still didn't get anything going. I do have.
Did you change the ETH0 to the Tune 0?
Yes.
Okay.
Yes, and it still is not showing through that. The ping is going through. I am getting on the one screen that I got a packet from Tune on the client, but never on the server.
Okay. All right.
So I'm right there at the cusp of it, but I'm not on it.
Right,
and
right.
It's probably something to do with that route. I'm probably just doing something wrong. Now it's time to go find my book.
Yeah. So what? Yeah. Let me see here.
Sounds like Daniel's basically where I was before I gave up.
Oh, thanks.
Don't give up. All right. So let's see. And 10.4.2.0. Okay, let me do this. I'm gonna draw a diagram of my, and then I'm gonna give you some commands and see if that's a little bit more. Okay. So the
good to me.
scenario should be, and this is probably in your book, So you have computer here, host you, right? And then you have here 10.0.2.6.8. And then here you have 10.0.2.6.9. And then here you have the VPN server. Okay, this is Tune 0. and it has a 10.4.2.5, right? And then over here you have host V. And that's going to be 192.168.60.6. And then over here is a 192.168.60.1, correct? All right, so now.
Yeah, that'll work.
Huh?
Yeah, that'll work.
All right, so now, and I think that's all of it. Oh, I forgot one here. So the other tune is 10.4.2.99. Okay, so on the VPN server, which is this one over here, well, maybe I'll just write them up here. You establish the tune, right? You do sudo if config tune 0 10.4.2.5.24 up, correct? That just sets this, correct?
Yes, adds the interface.
Okay, great. Then you have the route, right? So sudo route add -net 10.4.2.0.24. So because that's, you know, like what I was saying, so if a packet needs to return in that direction, right? But it's returning not through this line, it's returning kind of like that through the VPN. So that line is the VPN itself. And so that forwarding route sends it to tune 0. You see that? Daniel? This was the point of intention a second ago.
I think so. I'm checking my routes now.
Okay, so it's basically like there's a, you know, think of it, something came here and it requested something and now it needs to go back, right? So it needs to go back to that, through that same point where it came from. You see that?
So yeah, so the route then is on tune 0.
It's on VPN server because tune 0 is on VPN server.
Yes, yes, and mine's set up like that.
Okay, all right. So that's where you had issues before. That's what I was giving you. Okay. Now let's think on the other end on VPN client, right? So on VPN client, you have to think about this one a little bit. What do you run here? You run the client software, correct? The client C file. You also enable tune 0 over there. And what are you going to do over here? You're sudo if config tune 0 10.4.2.99, which is this one, -24 up, right? Then you do pretty much the same rule that you did over here because it's kind of the same thing. A packet came from it, and now you need the answer to go back into it. You see that? Guys, can you?
Yes.
Okay. Does that make sense?
Yeah, it does.
Okay, so I'm going to repeat then sudo route add -net 10.4.2.0, just like this one, -24, send it to tune 0.
Yeah, yeah.
Okay. All right.
See, but it's not getting a return on the packet. I am getting the packet from Tune. The route's all there. It's just not going through. It's receiving it on one side of the VPN and not the other. I wonder if I got something wrong with the code.
Now, one last thing I will say is when a packet comes from here, right? Let's say a packet originated at one, and this might be confusing, but it originated at 192.168.60, right? Then it goes in here. Remember that this is almost like a NAT. Not a NAT, sorry. It's an encapsulation. So the packet that was a 192.168.60 gets encapsulated in a 10.4.2.0 packet. Do you see that?
Yes, that makes entirely good sense.
Yeah, so it goes through all of that, right? But when it comes out, what Tune 0 does is it de-encapsulates it. So it takes that out, and what it puts in the network is a 192.168.60 packet. Do you see that, guys?
Okay.
All right. And so, but that packet that came through there, right? It came from over here. Now, let's say it's a packet that's requesting information, right? It may need to go back into the tunnel. You see that? It needs to be re-encapsulated so it can make it across. And so here's a little complicated rule, right? You know, you might need these rules, right? Like sudo route add -net 192.168.60.024. Where do you send it?
Well, currently it's sent through my one going to the server, so we need to send that through the Tune also.
Perfect. Perfect. That's it. You see that? You know, that's the thing with this lab is you have to really build all the routing. And this is why, if you remember, when I always say, for this, we're going to use the wizard on ASX, right? Because it really does all of this for you. But that's pretty much the idea here, okay?
So do we need to remove the other route that we have in there for the other device?
Which other route? Which other device? On this slide, you mean?
Yeah. So when you set this up initially, it'll have the 10. Let's see here. Like for on that unit, you'll have this one right here, the 10.2.68.
Oh, you can write on mine? Oh, nice. All right.
Yeah, annotate. So you can take in that, it'll go be using that interface to go to this interface here. And so this will be in the route. So we need to probably remove the one that's in that route and then add the one for this to go to the Tune route. I don't know. I'll have to try it both ways and see if it.
I'm sorry. In which machine would you add a new route? First of all, which one?
The client. Actually, you'd probably have to do it on both the client and the server.
Okay, so you're saying here on client, right? You want to add yet another route. What is that route for?
Well, no. When you initially set up the network and it's pinging over through the gateway, it sets that route.
It should do it. They're in NAT, right? So I don't think you need a route for that. You just have, they're both connect. So I don't know if you mean this one and VPN server. They're both the 10.0.2, 0 network, correct?
Yes. Yeah. Yes.
And so they're already connected. They know each other.
Correct.
Like this interface and this interface know each other. They're in the same. This guy drops a packet in the switch.
Yep. They're local, basically.
Yeah, this guy will see it.
Mm-hmm. What I'm getting at, though, is that for the 1060 network you got over here.
1060 network.
On the client, on the U unit.
Where's the 1060 network?
It's this network here. This network here.
Mark it again. Oh.
This one. Yeah, let me clear this and get
1060.
bigger. Let me make my marker a little bigger.
You mean 192.168.60?
I'm sorry. Yes, 192.168.60.
Okay.
This network here. Sorry. when I pulled my route up, it's
So
already
that
got,
network, okay, what about it?
it's already got this thing going through the port, the network port for here, instead of through the ton.
Okay, so that packet, all right, you're saying that it goes through ETH0 or whatever, ENS33?
Yeah, that's what it is on mine. Yeah.
Okay. So if a packet, you initiate a packet for the destination of 192.168.60, right?
Mm-hmm.
It should not, okay, so it should not go through ENS33. It should go through tune 0 because remember, this is the ASA.
Mm-hmm.
Will. That's the ASA from our physical lab network. Nothing can get through there. So basically this IP or whatever is a mystery. So the only way that it should get through is through the ton.
Okay.
And that is why actually in VPN Client, that's the rule that we added here, right? This network, 192.168.60 is this exact same network, 192.198.60 here.
Yes. Yeah.
Does that make sense, Daniel?
Yes, it does. So basically it answers my question. We do need to remove that while we were pinging initially to see if we had connectivity. When we do the initial ping, it puts that route in there, and then you'll have to add your firewall.
Right. So I think what you're saying is that you were trying to ping from here all the way to here.
Yes.
Okay. So remember what I said when I said that? I just said that assumes that this guy is a router.
Yes.
It would have been like we're going from switch 2 to switch 3 in our physical network. But remember that for our problem, this is an ASA. Therefore, yeah, you need to remove that route. So maybe for testing, that's great. You did a good job. You were able to ping from here all the way to here, but it's based in our class, as we had it, you would have gone from switch 2 to switch 3. The lab requires you to go from switch 2 to switch 1. And so we need to change the parameters a little bit for that.
Okay.
Okay, make sense?
Yes, thank you.
Okay, that's great. I know we're out of time, guys. I really wanted, let me just really extremely quickly. I added, so on VPN Client, we added that, so we were done with that. Do you guys think that you need any routing rules on host V? That's I promise I'll stop here. So I'm just putting that question out there for you guys. Do you think you need a routing rule on host V?
Yes, you do. Pretty sure.
Can you explain how that one works, sir?
You would need to tell host V that when it gets a packet from the Tune 0 network, you would need to redirect that to its quote-unquote router, which means the in this example it would be the 192.168.60.1.
Okay. Did you test that to see it worked?
Well, I got well, I know I put that in. It didn't seem to help my tunneling issue or anything else. I couldn't ping from host V to the server when I thought I should be able to, but I couldn't.
Question, but I mean, like, if you have on your host V, if you have that as set up on that one, that your ASA is your default gateway, do you still
Okay, so you're saying that on host, this is your default gateway, 61, okay?
Yeah.
60, yeah. What's your question? I'm sorry?
If you already have it set as your default gateway, do you still have to set that route?
Oh, okay. So the problem is host V Oh, that's I see your point. You're saying, well, I'm sending things to the network 10. V is sending a packet to 10.4.2, right? So it doesn't know where to send it, so it sends it to gateway, and then gateway now receives it, correct?
Correct.
Right, okay.
So from my understanding, you would have to have routing enabled on host V, because now if you have data from Tune, it would have to be sent to the tunnel. And then if you were getting data from the tunnel itself, it would have to be sent to the Tune interface, correct? And then from there, you could, I'm not sure.
Yeah, so there, you know, this is a good question. What is basically our question right now boils down to what is the route for host V, right? Now host V, host V in theory, if it's in the inside network, it should be able to ping.
I should be able to ping the default gateway, which is like the AS, which would be the
Right,
AS.
it definitely should be able to ping this one, 192.168.61. Technically, because it's coming from the file, it should even ping this one, 10.02.69. The question is, though, when it's in the tunnel itself, right? When it's an application in the tunnel, you know, this, right? So if it gets a packet, so I'm thinking, I'm going to write this above here, over here, guys. So I'm going to say sudo route add, right, -net. So we probably need a way to tell it 10.4.2 0.24, right? So whenever we have that kind of packet, where do we send that to? You guys know what I mean? Well, that's the issue.
Okay, but when you first get the packet from Tune 0, which is on .68, or I mean 99, and it sends it to Tune 0.
So a packet from here, right? So
Yes, goes to .5.
Okay. Yes.
Doesn't it, like, once it gets here, doesn't it have like it, like, you know how you did before, how this was?
Yeah, it would come out as something
Yes.
possibly.
Wouldn't that have the host
The
IP
192, you mean?
to there?
The 192?
Yes.
Yes. And then it's in that network, right?
Yes.
It comes out to that network.
Yes.
So that sounds right. That sounds correct to me. And then,
It would know to send it there. I think.
but then the problem is, it gets here, and then it needs to go back, right? And that's the route that I'm concerned.
Okay, I get it now.
You get what I'm saying?
Yes.
Yeah, it's not that it came out, you know, it came back out, and it's great, like, if you got your information, but what if you still need to reply back? So, and that's what I'm thinking here right now.
Wait, I just thought of something. You said that with the encapsulation, by the time host V gets the packet, instead of it being from the Tune 0, it would look like it was from its own network, right? It would basically turn into a 192.168.60.
Okay.
Well, I had thought that because before with the command that I just mentioned to you, I had it as when you get a packet from the Tune 0, forward it to the, well, basically the ASA, right? Well, what if you reverse it? Because with your logic with that encapsulation, you're getting it from like supposedly your own network, right? But so maybe then flip flop the two, see what happens. I don't know.
Okay. Let me do this, guys. Let me think about this. Let's just conclude that we probably need a route in V, okay? So we probably need a route in V. Let me think about this a little bit more, and I will, post it somewhere on in the lab, okay? But I want to give you the exact one, and I'm thinking about this right now, okay?
Okay.
All right.
So for the lab, do
Yeah,
we
go
want to
ahead.
follow the numbers you've got here, the 1042?
You don't have to follow the numbers I have used. No, this is just,
Okay.
Yeah.
you can use
Just
your own.
ensure our routes are according to what
Exactly.
network we use.
The only,
Okay.
so I actually, my recommendation would be honestly use your own numbers, because when you use your own numbers, you really have to really understand the routings. Does that make sense?
Yep.
Okay.
Yeah. So that's really actually probably better for you. You're learning. I believe all of this is correct. I will recheck my numbers again, and I owe you one route. I need to think about that a little bit more. Okay?
Yeah, I think some of the trouble right now is that people are trying to correlate some of the numbers you've got to the PDF and trying to correspond it. And if we just truly understand it and have our own network established, we can get it
I
working
believe
our
that
own way.
what you just said is the right thing. And and honestly, I'm not using the numbers from the PDF. So
Yeah, I think there's just like some, miscommunication on that part. So people are getting mixed up is all.
I think what's important is really this, right? Understanding. If just like I'm sending a packet, it needs to hit this. Okay, how do I route that? That don't like type the things in the PDF. Use that for syntax, and then as you said, Nathan, just then okay, these are the numbers that I think should go there.
Mm-hmm. Yeah, because just like you had the two tune zeros in this explanation here, like the 4.2.99 to the 4.2.5. That's obviously different than the numbers we've been using, but that clearly portrays what we need to be doing.
Yeah, exactly.
The connection made.
It doesn't matter what network spectrum you use, as long as it's the same one throughout your entire.
Right, exactly. Just use the syntax of how to do it, and then obviously the logic of where routes need to be for this to make it to that place, and so on. Okay?
Sounds good.
All right, thank you guys. So
thank you.
A little over. So what I'm gonna do is let me think about this one again. I will probably try to, again, I will use some set of numbers and then draw it out and then give you the commands in there. And that should work.
Excellent.
Okay, thank you.
Thank you.
great.
Yeah.
All
Have a
right,
good night.
so good night. We'll continue on Tuesday with TLS. Okay.
Very good.
Thank you.
Okay.
All right, see you guys.
Have a good night.
Good night.